So today we have a really big plan of a body swapped drone. So I have this drone here. I don't remember where I got it from, but it's just one of these simple drones. This is also known as a quadcopter drone for the design of the four propellers in a square formation. That's what a quadcopter is. It has two batteries. They're little 3.7 volt. I didn't see the amps, like amp hours or anything, but they just click in there. And the entire thing, it's not super heavy, but it's not super light either. So we're gonna try to body swap it into one kind of like a bomber style plane drone. You know, like some of those military ones that you see. So instead of the propellers being in a square, they'll be in a line and facing one direction. So let's get straight into disassembling it and then getting our measurements. We're also going to do a redesign of the controller just to make it a little more, instead of quadcopter, to be a more style of little operator. So let's just get straight into it. So first thing I think we should get into is the actual drone itself. So what we're going to do first is let's just take off the bottom compartments. So let's get that battery out of there. So let's try to get all of the hardware, all the electrical out there before, and let's see what we're actually working with. So I can see that there's a little camera on the bottom right there. That's probably for bottom sensing. Let's just unscrew this here. These are really small screws. So boom. Let's see if this is this does just come off. Okay, it looks like the camera has its own board connected to another board with four thicker wires and two smaller wires. Let's see if we can disconnect that. One. We're just gonna disconnect it for now. So that's the little camera setup. We're just gonna disconnect it for now, so where we can start with the rest of it. There's a little screw, so can't try to not lose those. I think we should just start by taking the screws off the arms. I'm gonna get some of my pliers here, so where I can easily grab the screws. Help guide them out better. It's about. I think the screws themselves are magnetic. So I don't want to strip that. Okay, I think I've already just stripped that. Oh, yep, that is definitely stripped. There's all that gunk on top. Oopsie. You gotta be kidding me. Let's try to be a little more careful. I did get it out though. Okay, it looks like this section. Dang, that is a really light piece. That's. But there we go, so this screws you this section out. Yeah, I forgot to take a total weight. I'll do a weight of the finished pieces. Check. That is a bigger screw. Let's just move the arm a little bit. Okay, the arm is like it looks like a shaft. I think it might be hooked up to a total motor that's distributing. I'm not sure though. There's a bunch of screws though. We're gonna try to reuse these screws. The hardest thing was probably gonna be the design. The thumbnail's probably gonna have something to show what actually, because so far I haven't said what I'm actually doing. Well, I've said what I'm doing, but I haven't like showed a picture of anything. There's usually two main types of drones, and there's quadcopters, which is the one I'm taking apart right now, and then there's other, they look like RC planes, which is basically what I'm doing. I'm gonna body swap this quad into like a small RC plane, basically. Dang, this thing has more screws than a Nerf gun, bro. But hopefully, well, I think that these metal bars are support bars and not actually like motors or anything, but I think they might actually be motors. I'm trying to separate the screws. There's these shorter ones and there's these longer ones with it looks like what Loctite on them. Like a white Loctite. Looks like I just have these back screws, and that should be it for top. Yeah, look, A2, B2, B1, A2, B2, A2. Yeah, so they have markings. Just a bunch of screws though. This is probably gonna have to be a two-part video. Right now it is 9 p.m. and I'm probably going to be working on this until 12, maybe later. I'm not planning on this being a super easy project. This is probably a complex project compared to most of the ones that I've done. Like the giant pen build. You see, look, this is one of those screws with the stuff on them. I don't know, I'm not gonna put it back together anyway, but I don't know. Okay, that screw's out of reach. I'm gonna have to use something else. I'm gonna have to go find a small screwdriver. But so I just have these two screws and then the ones around here. And then that should be done for the screw. You can actually see what's on the inside. See what we're working with here and how actually complex. So what my plan to do right now is to strip it of everything. As in fully clear it of all the internals and then weigh it and weigh the batteries, because these batteries, this outer casing I'm most likely going to keep because it fixated these to like a little board, and then it has the thicker battery, and these things weigh virtually nothing. If I would swap this like shell, it would be a lot of filament for printing, and I don't think it would be worth it. Let's see if I can get it out just a bit. No, okay. Yeah, I can't reach. I will be right back with a handheld screwdriver to get those apart. Okay, I came back with this little small screwdriver to get those parts. I think I should be able to. This one's a lot longer. Pretty tight in there. By the looks of it, like where the battery compartment is, it's a really hollowed out thing. Like, it doesn't look like there's any strong supports. And I hope that these little propellers have enough lift to hold a little bit heavier. I'm not planning on making it super heavy, but I need it heavy enough so it actually has structural support, because unlike this quadcopter, it's going to be touching down pretty rough just because of its layout. Quadcopters are usually for stability and like a resting air position, instead of constant flight like a little plane. So it's most likely going to have a lot more weight to it. So, okay, that's all the screws. Let's see if we can just open this. It looks like the top. Okay, there, I got the top panel off. The on and off button. It just looks like a little clicker. Here's the board. Here's a little LED. I'm gonna try to pop this panel out. See if I can save it. The front LEDs look like they're glued in. I'm gonna try to pop those out too, but looks really simple. There's the front LEDs, the rear LED, the wings, or what? I don't know a proper term. I think I might have to take off the wings to get them apart. Or not. Ooh, it's a gear. Oh. Okay, that's how it works then. push it. I'm gonna rewrap these. That's a really small motor. I know it's only running 3.7 volts, but that's still a really small motor. It's gonna be a long time designing this. Okay, it does push it up. Okay, so I'm gonna go get my notebook real quick. Okay, I'm back with the notebook and a pen, so let's start brainstorming how this is gonna go. So let's move that. So we have, here's the brain. So we have our little brain. We have rear light hooked up with 2 wires. Each wing is hooked up by 2 wires. Then we have 2 wires each for lights. And that looks like it. And then a center button. So, looks like the button in this one was a long shaft. Because it looks like a click. Yeah, it's just a click button. It is screwed in by 4 screws. So 1 here, 1 here, 1 here, 1 here. So that's about how the brain, that's just a very rough draft of the brain. And then we have this. So I can draw separate with the camera. I'm not gonna take this apart. I think I'm gonna salvage this. I might not use it entirely now that I'm thinking of it, because one of the reasons I'm doing this is because the app that goes with this is just fully shut down, like it's inaccessible. So, I mean, I could try to find another program to run it off of, but for now I'm gonna leave it because I'm gonna make it so you can screw and unscrew all of this. So if I could, I would design another body later. So for now, I'm just gonna do a rough draft, rough outline. Of this piece. I'm gonna say camera. Then motherboard. Okay, camera and the motherboard. So now let's look back at this wing. Here's going to be a challenging part. How can we line these up in unison? Those wires aren't very long. We need to line them up in unison. Let me unscrew this. It is a double D, okay. Double D rotator. Very small bearing. Double D rotator, small bearing. Let's move that over there. So I'm gonna have to pop that bearing out. Where are my markers here? I'm gonna have to do this for all of them too. This is a very planing video though. This is to see what I'm working on as I get my bearing out. Is this actually a bearing? Okay, we're gonna put that there. That motor, how does that come out? That looks like it's gonna have to be cut out. Yeah, the motor's gonna have to be cut out. Okay. So, the wing is gonna be wings. Okay, we're gonna do a side view really quick. Shaped like that. So that's a wing. What we're gonna have is the propeller out here with the rotator and then the big wing, the big double flap. And we're gonna have that, so let's draw our box. We're gonna have the 1, 2 on each side, not that close together. Let me redo that. So we're gonna do, there's 2 wings on each side. So we're gonna do 1, 2, and the bars. 1, 2 bars, like that. And then the center head about with the little flap, with little side flaps. Doesn't matter, it's a rough draft. Super rough. And then the brain, the wires, lights, rear light, and then we have to all make sure this is connected. So I'm going to label all of these wires, make sure everything is all labeled so where I don't mismatch them. And if I do mismatch them, it should be able to be removable and everything, so where I can make sure it's all ready. So I'm gonna be right back. I'm gonna go grab my little gram weigher. I'll be right back. So I have here with me my miniature scale, so we can get a rough estimate of all of the parts. So we're gonna do, this is the lower part of a wing, it's 2 grams. And then the thicker top upper piece, it's 13, so these aren't looking good numbers. How heavy is the battery itself? Okay, the battery is 32.8 grams. That's not a good number. We're getting rid of this, but 16 grams for the head. So that means a complete body. I don't think it's gonna, I think it's gonna max it out. Nope. That's 100 with the battery. So let's just say, oh, front came off really easily. Okay, that's 100 plus, so 103. 103, 119, 121 is a 134, and then we'll just say that all the screws and stuff was like 2 grams, so we're gonna try to aim to get about 140 grams total. So that is the total amount that I'm going to try to be under to still make it have good speed and weight and to actually make it handle itself. So this motor looks like has pins. I'm gonna get my cutters. I'm not gonna be able to get this out normally, so I'm just gonna give a little snip around the motor. Try not to damage it at all. It looks like a really simple design though. It's not super complex, but it's also not super easy. It's pretty straightforward though. We also need to determine length, wingspan. Get all good numbers with those. I already made the first cut. So, oh, are you telling me that I could have just? Okay. So I just cut that for no reason. You gotta be kidding me. So you can just slide them out. Okay, if you're doing this, don't cut. It's all removable by just sliding it out. I'm most likely going to take this out too. So the light, at the front light section, it's just bulbs into a plastic piece. So let's label this. I'm gonna go grab a piece of paper and tape and stuff, and I'm gonna label that. So I have a piece of paper and tape now, so let's get labeling. Where'd my pen go? This is where I just had it. Oh, it's right here. Okay. What was that? Front right. Front right. I left my scissors, so I'm just gonna tear it. I just got ink all over my finger. I'm just cutting the tape, cutting a piece of tape off. Sticking that straight to the motor. this is the best place to put it. Okay, first motor complete. You know, the front right, front left, back right, back left. Now, I'm just gonna finish getting the electronics out. This looks like it's just clamped in. Yeah. Just gonna loosen up the motherboard. So basically I gotta design a full body. And I gotta get all these electronics out. I'm gonna weigh it all. See how much grams I'm working with. It's a little hard to see right now. Got a lot working on right now. Yeah, on the back of the propeller is the double D insert. So those. Snap this open. Ooh, okay, that comes out. That's good to know. That little pin. Okay, I gotta make a little sit for it. And then the bearing. This is back right. Now this is like the raw version of the footage. I'm gonna upload this one first, but I'm gonna try to edit it later. This is already 36 minutes in, or 34. Got a little piece of tape ready. But it looks like there's going to be a lot of design that I have to prepare for. Like with the clearance of the motors and everything. I think these motor wires are long. luckily with this one, because the wires, because it had a fold, because it had like a fold, so where you could fold the arms in. These wires are super long, meaning that I can have a pretty good span without it putting a bunch of stress. And I just have 2 more to clear out. But it's still not super ideal length. I might have to shimmy up some contraption with extra wires, because these are pretty short. I'm just gonna loosen up this back one. Okay, oh my gosh, this bottom plastic off. It's like really squishy. So, hoo-wee. Look at that flex. Look, I'm barely pushing on it and it's flexing. Like everything is just flexing. It's super weak. Yeah, I'm gonna print a strong body. It's just, almost fully done with taking all the electricals out. There's this weird lubricant. It's like yellow. Yeah, so I gotta design a little sit for the bearing, measure out all of this so where it'll sit correctly. Luckily I have all the old parts, so where I can measure them a lot better. Apply a little pressure. Ooh. Just enough pressure to get it through. Yeah, I gotta make sure these things are labeled though. One little slip up and it could just be doing circles. This front left. And because it's going to be an outside project, like it's made to be flown outside, it's going to need to be able to withstand a lot of that. This screwdriver's so good. Best 50 bucks I've ever spent on a tool. Only 50 bucks I've ever spent on a tool. Most expensive thing in my workshop other than the workshop. Like, I don't know. I think you can find these drones on like Temu, Alibaba, Amazon. Like, these aren't good drones. I'm not saying go buy some all-star drone. The sole purpose of body swapping it. I mean, you could. It would look a lot nicer. It would perform so much better. But that's not the point of this. The point of this is to take something bad and make it look really cool. not bad, just not super good. And there's weird lubrications everywhere. Just gotta continue to struggle trying to get this motor out. Yeah, you can see like all that weird, like greenish yellow lubricant on the inside. Super weird. Never seen it before. Only lubricant I really see is like clear white. Okay, we got all the electronics out. It is really simple build. So, see if I can, no, I can't really. We'll use this. So what I'm gonna do is I'm gonna put it on the scale. So where that'll be its new 0, then I'm gonna take it off the scale. So where now it's in the negative value, and I'll put everything in, so where I have my little carriage where it'll hold everything, then I put it on. Now the weight of all the electronics is 24 grams. Then let's throw in the propellers and the battery to see its actual total weight. There's everything. So 68.92 grams. 68.92 grams. So that is total weight, everything needed for it to function. So the body can be about 80 grams of weight in total. It's probably going to be more than that because 3D printing is usually a lot heavier than injection molding. And I didn't account for like the bearings and the shaft. But this is going to be a project. Let's go. I'm going to go grab my computer, clean up the workspace a little bit. Oh, wait, hold up. Let's work on the controller. Let's take this controller apart just to see what we're working with here. Looks like it's about the same size grid. Yeah, they're about the same size. Okay, I can't use my electric screwdriver. I'm gonna revert back to this one. Dang. Hold up. Dang. Probably take the batteries out. Okay, so it has 4 buttons on the side, on and off. I don't know what that means. This little like flap. Okay, looks like these screws are a lot bigger. Okay, yeah, they're like 2-3 times the size. I also got to do a little research on how to effectively design a plane. Or even just find a model. I don't know what the scale would be though. I would have to measure out max wingspan. I'm guessing it's going to be pretty smaller sized. You know, one of those foam planes from Dollar Tree size. I don't expect it to be super big, but I hope it's also not super small, so I won't be able to see it. Still don't know what color I'm going to make it out of though. It's most likely going to be like a black. Let's take the batteries out. Dang, what are those batteries? Long life, alkaline, do not recharge, AA, made in China, long life. Never heard of that. Yeah. I think they're about to explode. Probably should just immediately get rid of these. And let's just split it down the middle. Oh, okay, lost the button. Got the button back. Okay, I lost the other button. Oh, it's sitting right there. Looks like it's very simple. Very, very simple. Just the back side with the batteries. Front side, the, so I don't even know. Motherboard. I only see 2 wires right now. Let's unscrew this phone mount. Goofy off phone mount. There's a massive spring back there. I don't think I should unscrew this. Come on! Ah. Something fell out. It's these things. Look at that. That's what holds in this rotating piece. So I could just push it down there. Okay. Got that out. Got that out of the way. No buttons. These are the things that hold that in. So again, super simple model. Looks like screw 1, 2, 3, 4. I feel like I can use this again. Oopsie. I'm using definitely the wrong size bit. I'm using it much smaller. Okay. Should get the bigger bit. This might be way too big, but worth a shot. Oh, works perfect. Just leave those there. Okay, motherboard is out. Looks like it's just these. And then it's 2 small buttons. I don't know what these on and what that trim button does. There's the shell out. There an actual point just into that. Oh yeah, it is connected. So I'm thinking that I just might keep the back panel, because I don't think I can. I think I just might keep the entire controller now I'm thinking about it. Just because of how minimalistic it is, and I don't think I can change anything about it. It would be a little too difficult too, so let's just put it back together if I can. So I'm gonna leave this off though, the front or whatever. Doesn't expose anything, right? Yeah. Screw it back in. Put that bait back in. It's these ones. Making sure to strip them as I put them in. Just put it in. Dropped it. Okay, let's just. Come on, you can do it. You can do it. It's around. Oh, I just caught that. I'm about to start checking if I'm Spider-Man, bro. What's going on upstairs? Pros of living in the basement. I get to do fun stuff like this. Cons. So I don't even know what's happening upstairs. Oh. I forgot to put it on and off in. So I'm not gonna be able to shimmy that in. I gotta unscrew it. Well, it's already 53-minute long video. Cheese. I should put them upside down. I should have took the controller apart. I should have known that it would have ended up like this. Right? Couldn't do anything. Just because of how it's laid out. So what does trim mean though? That's all the button says is trim. I'm like, bro. think I could do is get a new PCB from today's sponsor, PCB Way. No, I'm kidding. I do recommend them though. Me personally, I've never done any business with them, but I've like heard they're really good. So, hey, if somebody says they cool, they cool. Don't ever live by that. Yeah, someone also said it's cool to put milk and ice. That's absolutely diabolical. Nobody should suffer through the pain of milk and ice. I forgot which one of these is which. Eeny, meeny, no. Should be this one. Nope, is it this one? Is it? I'm gonna shimmy around there. Should I stay or should I go? I think that's all. That's as far as it goes. Well, it's because this is annoying. Come on. You can do it. Maron. I'm sure we'll use this one because it's longer. Perfect. Maron. Maron. King Von. Word to them dead ops. Okay, so we're just gonna have to live with these. Weird. Oh, now there's a big gap in the middle. Let's go. I gotta put their extra battery. Why does that actually fit? Hold up. It's like right there fitting. Come on, bruh. Come on, bruh. Ow, gee. Okay. Okay, well, now we know what we're working with. We know how this is probably gonna go, chat. So let's just tidy up the area a little bit and then get ready to bring over my computer and actually do a little research or maybe even find an online model, hopefully a very size accurate plane. Because if we can find an online model, that would be really, really helpful. So I gotta make that online model printable. That's gonna be super long, but time I consider worth. computer. Okay, we are officially 1 hour into the project, and what we've achieved so far is that we've taken apart the entire thing, stripped it of the electronics. I don't have any good CAD service other than Tinkercad, which is one I'm gonna have to end up using, which I don't have a problem with, but okay. We have our little work plane on Tinkercad. So I'm going to scoop this up a little bit. Just a little bit. A little more, so you can actually see the computer screen. There. Now, model planes. Alright, let's just search up RC plane template. Well, let's actually just show what I'm trying to actually do. So these are all quadcopters, but I'm trying to find here like that, but not that specifically. Like that style drone. Yeah, like one of these. One of the RQ-1 Predators, or the MQ-9 Reaper. Just like these, any of these three over here. 1, 2, or 3. Well, where would we start? Let's start scale. I'm gonna go grab my caliper. Okay, I have my caliper here. So we're gonna measure what wingspan would generally be. So I'm right here with this. These motors are low heavy. And weighted the entire thing, these things would weigh a ton. So it would be about that wingspan. So from the end of the notebook to the touchpad. Let's just see that. So 100, 200. This is not a good way to measure. This is just an estimate. 300, 350. 350 millimeters from propeller to propeller. So 400, let's just say 400 wingspan. Oh. Reader RC. I'm gonna search up STL. See if they have any ones out there. But not a single driven propeller. I want before propel. So I'm so good at spelling, trust me. Okay, let's remove the propeller. Oh, make a world. Okay. Please, bro. I really don't want to have to design it by myself. Ooh, okay, this is really laggy. I'm just gonna click off this. Let's open up Copilot. Dang, okay, it's really laggy right now. Okay. I want to body swap a RC and RC quadcopter to plane style. To plane style. RC with 3D printed body. Ew. The propellers to fit on two wings. Okay, let's just see what it'll give me. Good news. The quadruplane conversion doable, small layout. I'm not all for motors. Quad plane, correct? Yeah, the original like electronics and stuff. Yes, all for prop stay vertical, yes. No. No. Forward facing. No.
Yes, multi-engine plate. Controller. Yes. Yes, you're expecting an X or plus layout, not a straight line. So it can't do its math correctly. It's a fixed wing with 4 motors, yes. 4 motor plane using quad parts. Okay, equal gaps. 2, 3 sections of carbon rod. Slide. Okay, so it's basically telling me don't do this. Okay, what if I just... What about... No, because I don't have any monitor. I don't have anything to run it off of. Okay, what would happen if I lined them up? Okay. Yes, roll control. Use roll by speed with doors at one side and slide and the other with all fingers to see one. Seems like I'm going to do 0, 130. Line, but facing up and it's all painful. Okay, but the actual balancing thing is up on the board. Is in board, which is in the center this is getting me angry because it's like, no, you shouldn't be doing this. Yeah, okay. No, so those are these motors here, that motor there, yes. Okay, so it's like we're tilting left, so increase left torque. So wouldn't that mean it would just fly straight? And then not left and not right? Because it would reduce it? Yes. Imagine a seesaw. It thinks you have one kid on each end. Tell the right tells the kid, tells the right kid to push harder, and the left kid to relax. In reality, moved all the kids to the middle of the seesaw. Okay, what about where would they have to go for it to still look like Come on, please, Speed, I need this. Yes, this is the right question. Boy, if you don't... Okay, be honest. You can raise them so it won't be into plane. It's going to be stretched to vertical. Okay, so it's basically telling me just body swap it just to make it continue to look like a drone. I'm not super mad at that. Should I stay or should I go? Okay, but okay, well, I still have homework paper, so what if I do okay, what about if the two fronts are at the edges of the wing and the two back are much closer to the center. But okay, so basically what I'm trying to do So basically what I'm trying to do is put motor 1, motor 2, motor 3, motor 4 board wires. Like that. See? So where they're a lot tighter together, because you see on like a plane like this, it has the two smaller ones on the back and the two ones back here. So where I could just take basically this entire model and put the propellers there, the propellers there. Front two, we are close to the center, all facing up. Yes. It's a trapezoid, yes. We can work with that. Let's go. Okay. Motor must match. 1, 2, 3, 4. Yes, front left, front right, rear left. Okay, I labeled that. Let's go. If I slant them a little, would it continue to move forward, or should I keep the design straight? I want to ask if I can slant them a little forward so where it'll continually move. For first build is clean to keep the motor straight up. Tilt the motors. Okay, so we have our design. Now is the long process of I am not tilting them, but I need help designing the entire thing. Okay, but that stays up. Okay, what does it say? No tilts is queen quad quad plane that actually flies. Buildable design. Okay, let's go. 400mm wingspan. That's correct, because then I can still fit it on my printer. There. So I have these like small magnets I can use to open and close the top. Those will be really helpful for easy access to all the controls and stuff. Okay, then center cord front to back, so 150 for the cord.
4 vertical motors, yes. Fuselage into the center. Optional tail, yes. Yes. Yes, I do know it is not needed. Okay. Let's see, what's the propeller span? Okay. It's a little big. Propeller wingspan is 140. Yes. Okay. Yeah, 380 to 400 wingspan, tip to tip, cord front to back, propeller 70. Yeah, so I'm designing up a trapezoid for the propellers. That's gonna be the final decision. Okay. So let's hop over to Tinkercad and do quad plane. Perfect. Okay. Let's start. We want a curved shape for the tip of the propeller. It's 10. We've nope, way too much. Okay. We're just starting out with a basic just a little quarter. I wanted to angle down a little bit. Group. Okay. By 60 by 4 or by 160. What is the side? Measure. What's the wing? So I'm talking about like the propeller. Yes, wingspan. $150 is long. No, okay. Look, here's the motor. So the motor and like rest contraption. At max
This doesn't have a really long side length. Yes. Okay. Okay, 350. Expand. And then, not actually big is the motor. Because the motor itself is 9 millimeters in diameter. So 9 millimeters. It needs to be long enough to hold the shaft. Let's grab one of these and one of the propellers. So how far does a propeller slide onto this thing? Okay, just barely. But the length of this is what I need, basically. Because then I can just dig a hole. I need it to just be a little bit longer than this. That leaves space for the motor, right? Yeah, okay. I have to dig out the motor too. That's 22 tight. It's 20 couldn't. Okay, 20 is too tight. It have to be 25. Wait, hold up. Let's grab one of the actual wings. The lower section. No. Oh. Just kick the phone.
Put one of these back together with that piece in. So it just needs to be a little longer than to the edge of this. Because it's injection molded, it's gonna be a little smaller. Okay, no, that is 20. That is 20 millimeters. That's. Let's pull this back apart. This moving up and down doesn't matter, really. It just needs to rest onto that. Okay, that's good to know.
So 20 millimeters in height. There, double the length then 30, so we're moving that to 60. Do kind of look a little tall. So what's the span of this? Because this is what's going to really matter. It's 20. So it needs to be at least 26. Does feel a little tall though, even well, I know that those are thick. Let's just extend it out like 120. This is way more than we need, but so it needs for the wires to fall into a groove. So let me demonstrate that real quick. So here's the wing so far, what it's gonna end up being. That's the wing. Let me lower. Oh, yeah, okay. That's the wing, right? So the wing needs to supply the motor, the shaft with the little rotating piece, and there's a little bearing right here, and then it holds the propeller shaft, and then it needs a little groove for the wires to escape through. So let's do a top view. So here's the little rotator piece with the shaft. Here's the little motor. So there's the little motor, and then it needs a little space for the wires to move out of the way down so where it can repeat for the other one, where those will also lead to this like wire path basically, and then that would be times 2 for the other side. Well, oh wait, I forgot. I'm only doing 1 on each side. No, I don't need to do 2. So one of these is completely off grid. Let's go back to the computer now. So we just need it to fit the motor, the rotator. So the rotator is 20. So 25. Motor will fit in between that. We need space for the curve, so past the curve. Whatever's past this curve. And we also need to like hollow it out really. So I think it's been like an hour and 40 minutes. So we have like a base of the wing.
So I'm gonna have to cut the wing into 2 pieces though. So let's just delete this like motor thing. So we're gonna rotate it flat. And this needs 350 divided by 2. Let's just do 170. So that is the span of 1 wing. That's a really big wing. And then what we're basically gonna have is another one farther back, but like 100 on each side. And then model up a little back wing because I think it'll look cool. Even though it's gonna have literally no purpose. Something super simple like this. Not incredibly difficult or anything. I'm gonna redesign it to look a lot better though. It's just rough draft so far. Rough draft. And then a body. We're gonna put in a battery. Speaking of the battery situation, let's move away from the computer for now. These batteries got stuck to each other, right? I swear if these they're just like so what if I just copy this design of a battery cage? I think that would be really good. But okay, let's go back to the computer. So the first thing, I think we should design a housing instead of the wings, just for now. So we're actually
just grab all of these and move them out of the way really quick. Okay. Let's see if, plain STL. Let's just see if no, I'm just looking for like the most basic. When you search up plain. Like this, but like not like a little more blocky. Yeah, phone. Okay, bro, what is? Let's see if I was. Just see, boom, like that. The light, not. I just want like a curved front. But I don't want to actually make it myself. You know what I'm saying? Fine, I'm just gonna do it myself. So we have our curve. I'm just gonna rotate it a little bit. So this is gonna be the nose. I'm gonna make it so it fits this. I'll actually go tough. I'm gonna get rid of the battery. How long is this and how difficult would it be? Okay, finger. Okay, 55. No. How big do I actually want it though? Like, can you see small though? That's really tight. It's, yeah, really tight. About 40. I think there's a little more wiggle room. 45. 45 is actually really good. Yeah, we're gonna do 45. Make that a little taller. All fit looking dirty. The battery probably not. The battery contraption. Shit, let's push it. Okay, let's take apart the battery. I'm gonna take apart the battery. Doing a bunch of measurements right now. think of if instead of doing like keeping the casing of this battery, I should just raw case it. Or no casing it. You know what I'm saying? Just have a little indent inside the body. Here's the housing of the battery.
Here's the actual battery itself. Take this little foam piece off. So it is half an amp hour. 5 watts. 3.7 volt. Yes, okay, so we can just make a custom housing to continuously hold the battery. I think I might just get rid of the lights. I don't need them for anything. I mean, I'll keep the backlight, put it on the fan. Okay, let's very carefully snip that. Very, very carefully. I just think that I'm not going to use the lights. It's just more work for me. Why bother? And this thing's bad when the light wires are the same size as the motor wires. Like on my other bike build that I'm doing right now, the light size, light wire size is so much. It's like, I think it's like this size, like those wire size, and then the battery leads are like super thick. Let's see if I have them. I don't even know where I put all my wires. Like I got like a bunch of leftover wires. All of my projects I do. I don't know, I'll find it later. But
Okay, this is a really, really good thing to know. The battery exposed with no layer over it should fire it's in electrical tape as reserves cover. No, I probably shouldn't have told it that. It was gonna be like, "Wah, wah, 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 wah. Heat trigger battery wrap, cradler shell, foam padding, basically just strap it down a little bit. What? I'm not going to strap it down, I'm probably just going to use magnets to hold it down. I got a box of these magnets. I think I already showed these, but... Okay, length. I think it's at 160. That sounds like a good number. 160. Let's make that a good number. $160. Okay. $45 in length. That to the ground. Move this over to it. Raise it up to 30. Yeah. In my opinion, I don't excel in anything, but I'm pretty good at stuff. Just base. Like, I can do everything equally decently. If that makes sense. Okay, now we got our weird body. Okay, those wings are really long. Well, it's just a template, but they're really long wings. Yeah, what was that? Okay, we're gonna group that. Now we have our body. Move this up to 30. Make it 45 long. Make this 30 long. So go on that back. Probably could have rounded that, but I don't think it looks fine like that. Well, those aren't going to be super thick. Now, I'm going to do hollow out the center, make little holes. Not fully hollow it out. What I'm going to do is I'm going to copy it. It's got to be a pretty big open area. How tall long is the entire thing? 220?
I do believe that it should be strong, but what, a millimeter wall? Well, we'll say a millimeter wall is pretty thin. There's something printed I have that I think for weight wise, I should make it 2 millimeters in wall thickness. Just because it's already going to be pretty heavy compared to its original.
So let's clear out. So 220 minus the curve 30 and 190. So you can make this 190 degrees in length. And then minus 2. So it would be 188. And make it 43. No. What is 45, 2, 2, 4, 1, 41. And then skyrocket it to 50. And then 2. Now move it up 2. Now move this down. It's 28 tall. Move it down to 26. Now group it. There should be a massive air pocket in here. Okay, can't zoom in any farther. No, I'm going to copy paste it as a whole now. So that just leaves us undo. Down to bring it up to reset that. How am I going to do this? I'm going to make the back. Wait, it sticks out the back. I forgot about that. Forgot I gotta limit that off. Oh, what the? 188. One's 190 minus 3 is 170. No, 160. So 152. No, 158. I gotta make it slanted a little. Move this out first. Make a solid piece. Extend it by 2. Drop it down to so now that reaches up to the top. I'm basically going to do a hole here, so where I can put a magnet and then a little slide back here. So let's get another square. I get 45. Now we're going to make this 30 tall. And how tall is this? 28. So we'll do 27. Well, 28 off the ground. Should be flush with that. Nope. Okay, move it down one. Okay, let's go. I forgot this itself isn't. We're gonna do magnets in the back. We'll just do an indent on a little double magnet. C, Control V. C, Control V. Bro, I hate when that happens. No, how big is this? That lifts up pretty bad out in the front. It doesn't stick out the front though. Yeah, this. Bro, what do you mean it's sticking out that far? Okay. So I'm gonna move this out. Just shorten that lip. Can't be that far out. So degroup. I don't know how far, but we're just gonna make it 4. Three shapes. Put that, move it in 1. Okay. That's fine like that. No hole. How big is that hole? Whole piece. 177. So 41. Is it actually 41? 41. So let's move it to 40. I'm gonna move this. What is this? Double piece. 177. So move it to 176. That's 1 millimeter shorter. Is this panel? It's 1 millimeter shorter. So it'll be pretty tight in there. With that. Okay, now we have our body. That's very front heavy. It's gonna be pretty hollow anyway. So that theoretically so far fits. So something needs to be movable, so where I can get this in and out. I feel like keeping it as casing isn't really a bad idea anymore. I think I might put it back into its casing.
One side of the casing still makes it flat.
If I just wrap it in electrical tape.
Okay. So what I did was I just jimmy rigged a little system so where I can still use the bottom casing only. And I think I might put something inside so where it all holds it better. This can lay flat now. So like it can lay flat perfectly fine because it's all flat surface and it doesn't rub anywhere. So now I can have the little flat battery. I think I'm gonna do the same thing to the other one just later. So I'm gonna measure. What was that? Oh, it's the plastic. It's not good plastic. I was like, what was that?
Okay, so what I'm gonna do is I'm gonna finish up designing. I'm gonna finish up designing the internal cavity, and then that's gonna be it for part 1. This is 2 hours and 16 minutes in. That's gonna be it for part 1. So let's just finish up designing. Well, let's first see if this fits on here. Yeah, it does. So I just need to like screw this down with enough clearance so I can slide the battery in. One, two, three, four. Okay. Okay, I'm gonna have to skip on 1, 2, 3, 3 and 4 because that's just not how it's laid out. Boom, boom. So basically this isn't as big as you would think it is. I should probably shorten it. That's really long. Think about it. Okay, it has that now. The hardest part is probably going to be the motor designing. But I believe that once I do one of them, I can finish all the rest of them. But that's not what I'm going for right now. So I need a support bar. Is there anything under? Okay, I need support beams. Let's get the caliper. So where do I want the head? I'm gonna reuse all the old screws to hold it all in together. Okay, let's get to it now. So center to center, the holes. That is, let's just say 22. 22. Okay, so the cavity space, 2 on each is 45, and total 2 on each, 41. So 41 minus 22 is 19 divided by 2. 19 divided by 2 is 18, 9, 9 and a half. 9 and a half, so let's make a little bar here. How wide can I make it? Oh my, nothing. So basically you gotta do small cylinders. You have to do really small cylinders. Whatever this is. 4mm cylinders. Let's wait in the block. Okay, 4mm cylinders. this is going to be how it is, how the motherboard is. And pop the entire top panel open. So look, let me angle you over here. So here's going to be the board. It's going to be screwed down to the inside. The board is going to be screwed down like this, with like the little bars coming up and over here like this, and then this battery compartment that I have right here is going to slide under and into the bars, and I'm gonna have little guiding grooves so where it'll slide in correctly, so that's also where I can slide it out. And slide it out and charge it, slide it in. And then I also think that I should have so where I can slide it in and then not screw it down, but have a little like spring trap or something, like something to push it forward and keep it forward. Like a little panel I could screw down. And this is going to be 22 in length. Center to center 22. Center to center 22. And hole and hole. So I just make the whole cavity. I just make the whole cavity long. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 7 and a half. Or 15 of these clicks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Boom. And then this. That one is 20, so just throw it right there. Boom. That's also 40 tall now, so let's shorten it. This piece probably only needs to be 10. Move these all the way down to 10. Zero. Oh, I might take a little shorter too. Let's see how tall this is though. So this is how tall. This is height-wise, how tall it needs to be. Okay, let's see how much that is. I marked it on there. Also the little gap in between there. That'd be really good. Right now. Let's push it tight. It's 2 millimeters. Not a lot of room to work with. So 19 total. This entire thing has to be 19 tall. I think I should just. Let's just lower this down to 6. Okay, that's perfect now. Group. Now we need to cut out the holes. Let's see if I can find my test piece really quick. I have a screw fit test piece. I'll be right back.
Okay, there's nowhere in sight, so I'm just gonna
measure it by myself. So let's get one of these screws over here. Let's get the battery off. Battery over there for now. Get the screwdriver. It is officially 12 o'clock. New day. Okay, it is not this screw. I think it might be one of the bigger ones then. If not even the bigger ones. No, it's even the bigger ones. These are smaller but thicker. Oh, what ones are these? Is it these ones? These are really big though. These are like really, really big. No, it's not these ones. What? Which ones are they? Okay, now I'm lost. They're most likely gonna be short. Oh wait, no, they don't hold that. Oh, okay. Now, I'm just stupid. It would be dumb if they actually drilled into the board. They're just holes. the drill into the bottom piece. Is that magnetic? Oh. Okay, so now I have a 1mm holes. Okay. Bruh. Got that over there. 1mm holes. 1 by 1. I have absolutely no clue on. Let's just copy it. Oh, deep? I don't think that matters, does it? If it does, I'm cooked. Center the first one. Copy and paste it over. Center the second one. Okay, now. Let's pull it up like 5. It's 14. I don't think those are longer than 14. Okay, we've now finished our little motherboard base for the back side of it. Now let's go and throw it into our inner frame. Oh, you guys can see. So basically what I just did is I finished up this holder thing. I'm not gonna put it in place anywhere because I don't know how close or far I want it yet. I have a lot of room, just to show. So I'm most likely gonna put it about there because I still have the sidebars. Because I'm most likely gonna either find or print some rods so that I can hold it all in place. I'm most likely just gonna find a rod, or probably not even use one. I'll look and see if I have one. Okay, I don't have one, but I'm just gonna like print something that'll go through it, or yeah, like a dual rod, so where it'll just hold everything together. So let's just get to finishing up this motherboard holder, and then the battery. This makeshift battery. Let's just throw it in digitally. Let's first fix up this a little bit. Flatten that out. Go back to 1, delete that. Delete that. So this is what we have so far. Those in the back don't count. Those are just references, so we just delete them. What I'm thinking about for the wings is I'm just going to make a regular sized wing, and then the part that I do need the propellers for, I'm just going to raise it. Let's put the battery in digitally. About. that's the battery. Meaning that the battery will. I actually don't have a lot of space really. So I can scoot the battery back. Probably the front of the board. So there's the front of the board, there's there. Let's do the board too. Let's just say 3 or 2 millimeters in height. And then we'll do green for that. And let's just do blue. I like blue better. Just for this. And then we'll do red for parts that we're not keeping, as in parts to show. And then that button can just stay like that. I don't really need a button. Like, there's one of the things, it's like, it's nice to have one, but you know, not required. 55. 55. Now, how far can I make the off this hole? It is 13. Raise this 19. Okay, that's 26, and then how far am I supposed to off? 13, yeah, 13. One, two, three, four, five, six, 7, 8. Okay, that definitely works. And then the battery can easily fit in with a decent amount of room to spare. It'll be like that. I could do the aligning for the battery though. I think that's the aligning for the battery. I'm going to do some side lips. 41. How long is the battery? Battery is 29, so it's gonna have a whole of 31. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 5. Oop. Lower it down to 10. Lower down to 9. I just need the bars going across to hold this thing in, the motherboard. Because there's 2 screws at the very end, right where the battery is going to be. I'm thinking that I might do a separate piece. Like a separate piece. So I'm going to get my pen. So where it's like a side view. Here's the box. So here's the box, and then I have 2 bars like this, just like the other ones, and then a separate piece printed, so where I don't need supports like this, it would screw down and then would screw into the board. But it's a little late right now. That's all for today. Hope you enjoy this one. We're going to continue tomorrow, but that is what we have so far. So we have a rough blueprint. We have disassembled the parts. We have paper blueprints, digital blueprints. We have the ready for the battery and the stuff. So we need wings, motor mounts, finish the interior, design the exterior to look a little more better, and then print, assemble, test, finish. Thank you guys for watching. Goodbye. Okay guys, today it is a new day. This is like 6 to 8 hours after yesterday. We're just gonna get straight back into it. Today's hope is to finish designing everything and make sure everything is all measured up, because I know the wiring is gonna take a super long time. So let's just get straight into it. So what we left off with was this like shell. I have to re-measure all this to make sure it'll fit in though. But we have this like shell or body. So what we need to do is finish the inside compartment with all the electrical, and then design some wings, put the wings on the design, and then print everything up and see how it comes out. It should come out pretty good, I hope. So let's just get straight into it. So let's just look up plane. Let's just look up plane. So this is like a regular commercial plane, right? So it has the 2 motors on the side, the back wing, the fin, and then the body, and then the wheels. We're probably not gonna do any wheels, just because it's all big and flat. It looks like an aircraft carrier. So I'm basically gonna have these motors are just gonna be more centered and facing up on both sides, and then on the back, on the edges, they're also gonna be facing up. I think for look wise, I might slant them, because I think that I don't even think helicopter plane style, I don't think they have anything like this. Yeah, something like this, basically. But with the rear too, for stability. So that's actually a really good photo, like this. See, but with the rear ones, for stability. That's a really good photo. That's what we're gonna be aiming for. So, except it's not gonna be built like that because of how the motors and the bearings, wings are laid out. It's not gonna look like that. So, let's make sure this is all in. So, this is in the ground. Let's move this. So this looks like how the motor and so the red here, this is the battery. This upper red part is the board, and they're set like this because that's how the let me bring it down here. So here's the small battery. Here's the motherboard. So the battery is flipped over like this, so it would be facing like that. And then this would just slide under with those prongs and slide into place. You see that? And that's how it's laid out up here too. So what we need to do is let's move back down here. There's 2 screw holes. I'm gonna use something more exact. One here and one up here. So we need to make like a bar that goes across because that's where the battery goes. We need a bar that holds those screws into place. So where the motherboard is actually leveled inside. So what my plan is, I think I showed this yesterday. Yeah, right here. Well, my plan is to make a little like pillars right here and then a bar that it would be printed separately that can screw into it. Bro, what is happening now? So a bar that can screw into those pillars, like how the back of the motherboard is going to be set, just a little bit differently. Like same height and everything, but we just need to make room for that battery. Okay, let's just get straight into designing that. So let's get this piece out of here. And we're gonna copy it, and then, no, it's 1 millimeter in diameter for those holes. So we can do box, flatten it to this height. There, now widen it to the 41. Line it up with the other one. And then cut out the center, but let's make it a little shorter. So we want it about triple the size of the hole. So if the hole is 4, we want it 12 for support and stability. And then I'm gonna cut a section out of it. Okay, how tall is this? This is 19. So we want that extra bar to be 2. So let's bump this up to 16. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21, so 10 and a half, or 21 half intervals. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 19, 20, 21. Okay. That is centered. Group that. So those are our bar pillars, I believe. Oh, wait. Hold up. Undo. I didn't measure this. So how long is the battery? We want it to be as basically of this piece. Okay, so the battery is 29, so 31. Why did I measure it? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm just aligning this so it'll be the same as that back one. So where the battery will also sit flush on this. 1, 2, 3, 4, 5. Okay, there. Group. See, now there's that. And I still gotta measure it and everything. And now we have our, now this is gonna be our flat bar. So we want this 2 millimeters in thickness, super thin. We want it 12 in length. And because the entire thing's 41, we want it 40. So it'll still fit. So this is our bar, our panel. So now let's lift it up. Move it, center it, there. See? Now this is centered. So this lower section, this like lower section is going to be printed in the entire body, and then this upper section is going to be printed separately. But first we need to cut out holes and line it up with the front one. So let's move down to back to this caliper. Let's measure distance from holes. One more. This is 43 so far. Okay, 43 center to center. These things are magnetic. They have magnets in them with copper. So 43 to center, center to center. So this is 12 in total. 12, and this is 20. 12 plus 20 is 32. Minus the 43, 32. Minus 43 is 11. I still need to, let me just cut the holes out first. So, this is 2 millimeters. Let me grab one of these screws to see if it'll actually drill through the entire thing, or if I need to get some bigger screws, or even a magnet maybe. That's gonna come loose super easily. I'm gonna go see if I have any other screws that I can measure it to. I will be right back.
Okay, I have these. They're not super long,
But they're a lot longer than any of the other ones. They're decently heavy compared to the other ones. Let's see.
So that's 0.12. And this one is 0.33. So yeah, it's like 3 times heavier. But I mean, it should be worth it. I just hope this thing isn't super front heavy. I might have to hollow out the center. But I think it'll balance out with the battery being in the back. So let's... Also, I hope you guys know that I'm going into this with no plane experience, no nothing for designing planes and crafts of any sort. The best thing I did RC wise is I fixed up in RC car because this is the suspension broke. That's it. I didn't actually do anything with it. So let's measure these bigger screws. And let's write that down, that's 43. So 43 millimeters is the hole to hole. That's good to know. Okay, this screw is just under 3 millimeters, like 2.9. So let's just go to 2.9, 2.5, 2.5. Let's go and put these screws over there. So cylinder 2.5. 2.5. Okay, here's our hole. They're not super long. We're just gonna make it long enough. We're not gonna like do any indent because I don't think it. I think it would be better if they're showing. Okay, it is 10 millimeters in length. So let's bump it to 12. You should add real support to everything. These are a lot bigger holes than the 1 millimeter. Let's just move these out. Okay, I'm just centering it. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 19 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. That is perfectly centered. Doesn't stick out anywhere. Perfect. Okay, now we're gonna lock this. Lock. Oh no, let's just undo this. So what I'm gonna do is I'm just gonna tape
1, 2, let me, okay, let me grab a box, no. Okay, let me grab, oh my god. Cylinder, okay. Now move it up 0.25, just so where I can actually grab them. That won't affect the length at all. Okay. Cylinder, base, cylinder, Control C, Control V. Now move it over here. Group it. So now we have that hole. And then delete that. Shift. Group. Now we have that hole there. See? Now we have the two. Now we have the two pieces, two separate pieces. So let's put this one back over. Now we got to measure it out and then make the 1mm incisions. I think the best way is to just drag it over. Let's just measure it. Okay, we can set this to half. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16, 1, 2, 3, 4, 5, 6, 7, 8. Okay, that is centered. So that's center to center. Let's grab some 1mm holes. And we're going to cut out onto that panel piece. One. And 2. Okay, now how far off? It's 43. So do I just move it 43 out? I believe so. Center to center, it'll be close enough. So it's at 0.5, 0.5. I'm gonna set it to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 28, 29, 30, 31, 32, 33, 34, 35, 36, 38, 39, 40, 41, 42, 43. Boom. Okay. Now let's grab these holes, cut it out, and grab these two base plates. Group them together. Change them blue. Move them into place. Did I measure wrong, or did it just not go into place correctly? I got my cat here. It's 13 off. What did I measure wrong? No, those are on the edges. That's scratch. Okay. Okay, we good, chat. We cooking. So now I can bring that back to 0. So. Oh, I forgot about the clearances. Is that gonna cut it? No, I can just clip it a little bit if it doesn't. Not a very big deal. Okay, the gap from the hole to the wall cannot be... has to be shorter than 6 millimeters. So let's just grab this, shorten it to 6 millimeters. That's the panel. This is 6 millimeters, that's where it cuts off. So what if I just do this? No, what did I measure the 12 for? The length of this, yeah, but... Okay, let's just degroup it again. Take this and... let's just shorten it to 8. And as long as it's centered, it's the same thing. Let me group it. And get back to blue. There. Okay. And now we have... now we have the motherboard situation done. Well, the light. Speaking of the light, I would have to go up, but no, I'd have to go to the side. There's 2 in the middle to move it anywhere else. I don't know. I'll just leave it like bundled inside the light. So look, there's this little LED light to tell when it's on and off. I'm thinking I'm just gonna leave it off. Oh, not like connected it to anything. That's what I mean. See it? There's no batteries in my controller. Let's grab these long knife. Turn it on. All fly in unison. It's actually really cool. Like they're all rotating. Oh. Oh, what the? I think I made it think it's flying. Okay, that one's going really
a stop really quick. Land. I'm just gonna disconnect it. So I don't know what was happening. At least I know it's still working. Okay. Dang, it's been 30 minutes. Took 30 minutes to just finish this mounting. Okay. But now we have the motherboard mount, we have the battery mount. That should be all the internal electrical, right? Now is the hard part, the wings. Okay, let's... So I'm thinking of making a basic sized wing, and then let's get my notebook ready so where I can just demonstrate it instead of just blabber on for a while. Fresh new page. Okay. Wings or propellers or whatever. The next step is what I'm planning is we're just gonna make a simple wing like that, just like a super simple wing, and then have like a contraption above. Instead of the entire thing being lengthwise, we just have a contraption that's raised above it. So where I don't have to make the wing all big and bulky throughout everything, I can just make it bulky around the area that needs it. I also have to measure it all to make sure I don't offset it, because I think it will be fighting with itself. I also want the wings, like on this image, to be a little slanted. Just a little bit. So basically, here's the body. Really bad drawing of a body. And then we have the skinny wings on each side, and then the smaller skinny wings. Like that. And then the magnets for the top, the board, the battery, and the wires will go to a big, bulky propeller section. So where total weight is less, but these wings on the very end, in the back, they're going to, like the propeller span is probably going to be cutting it really close to the edge. Like that. So these propellers are going to be cutting it really, really close. The back ones are going to be cutting it really close to the body. And then it's going to have like a raised part, so we'll do a side view. a really bad side view, but that's about the side view. And then we could, like, if the wire reaches, we could have the little light back here. I don't think it will, though, because it's really far away. I'm a little worried that the propellers are not going to reach, and I'm going to have to move it back. Because this battery still needs to be removable, so there's no way I can rewire the battery either. So where the battery will be a permanent fixation. I mean, the only thing that I'm thinking of is if I move it all back, like I slide it all back, and then when I put the battery in and the motherboard in, I would have to just screw it in. And so charging the battery, like in between flight, would take a pretty long time. Because I would have to open it, unscrew the board, lift it up very carefully, take the battery out, put it back down, screw it back in, charge it, unscrew it, put it back in, and screw it back in. So let's just get to designing the wings, because I still don't know how they're going to actually hook up to the body yet. They can't be really heavy. They're going to be like the lightest section. I'm planning on doing 2 walls, 5% infill, maybe less, maybe like 3% infill, maybe 1 wall. I didn't even know. Look, I'm going to export this body and send it over to my slicer. Just see what an estimate of this would be is. Oh, I don't even have it open yet. Okay, well let's do a topical view of the wing. And then, so it is going to have the little motor, the little gearbox thing, which is this, hooks up to the motor. And then there's a super, I don't want to touch those. There's a super small bearing. So that's the 3 parts is the motor, the bearing, the shaft, and then the propeller goes on top, which is screwed in. But prepare, file, import. I'm keeping it down so you guys don't see my files. Okay. Here's our model on our build plane. Okay. Layer, height, line, seam, precision, wall, classic, strength. Okay. Go to the very top wall, 2 wall loops. Top and bottom. Top shell. Reduce that to 3. Infill gyroid. Oh no, solid infill. Okay, let's find the rectangular. Sparse infill density. We're gonna do 3%. Sparse infill is a gyroid. Fine with that. Supports. Enable for 30. On build plate only. Others. I don't think it needs another. Slice plate. Okay. That's a decent number. I'm fine with that. We got a total gram of 52.11, so it'll be pretty light. I don't think, oh,
Okay, I didn't include the inner pieces. So it'll probably 60. I'll just say 60. Yeah, okay. Yeah, it'll be pretty thin. Looks like the bottom is almost solid other than one set of infill. The front has 3% gyroid. Top is fine with a little bit, so this thing will be pretty light. That's really good. It'll take an hour and 13 minutes to print, but that's not including any of the other internal parts. This is a really good benchmark. Because let's go back to the older numbers. Like the actual weight of the original thing. Wasn't it? It was really light. It was 140 grams total and 68 grams worth of electronics and required parts like battery and stuff. So 68.92. So let's just say 70 plus 60. It's like 130. So we're 10 under, and we still need wings and stuff. So we'll probably be 40 over. 40 grams over. That's really good for it being injection molded to 3D printed. Just because I'm taking out some pretty heavy stuff. And I'm cutting down a lot because like my electrical tape battery compartment thing is a lot less material than if I just use the original shell. Yeah, but this is a really good benchmark to find out how much it's actually gonna be to print. Okay, let's go back to the designing. Okay, now's the really hard part, is the wings. I think we finished the inside. So what I'm going to do is I'm going to group this all together. Group. There. Now I can copy paste this, right? Yeah, okay. Now, let's get our actual number now. Export as an STL. Go over, prepare, delete, prepare file. No. File, import, plotplane, boom. Slice plate. 53. Did that go down? No, because it was 52, right? Yeah. So it was like 1 more gram for all the internal cavities. Okay, that's good. And then wings. Dang, man, this is a really long project. What? It's 42 minutes on this video. The last one was 2 hours and 40 minutes. So it's been like three hours. Okay, well let's just get straight into the wings. So, first of all, we need something to support the wings. If they're actually going to be this light, they're not going to be able to support their own weight. They're just going to be too weak. I'm thinking that I make 2 wings. Like I split the longer wings, I split it down the middle, and then I print a separate beam to go through it. I'm not sure about that though, because 350 divided by 2 does fit on my printer, so
I could do that.
Okay, well that's... Yeah, let's just get a design of the wings going up. Okay. So we're gonna reuse the curve. Let's just... Arrow. Wing. Like this. Even though it's not going to be in constant flight, that's what we're going to need. Like a teardrop. So it's... Let's get into designing that. So looks like it's like a bubble front, flat bottom. I don't want to use a lot of this curved piece, just because of its nature of requiring supports. How long does it need to be? Not super long, no? Well, it's the length of this, really. That's all what's needed. And to get around this, like the wires to get around. No, they don't even need to get around. So it needs to be like 20 millimeters. It would fit in 30. I think 30 would be a good number. A little longer. 40. 40 is good. That's a base template for the wing. That's not going to be really good to print though. I mean, unless it was flat. Yeah, we still want this design though. Oh. Group that really quick there. Here's our wing. And then this is going to be 320 in length. $320, what about 150? That's pretty small. Oh, it's coming through. That's not gonna work out in the center though. Maybe for the backside, yeah. I still no. Um, let's just give Copilot this model so far. I've modeled this up and turning into the limb of the wings, not through the body without running into the electronics. I'm thinking of a split wing with a bar of some sort to hold it together. Okay, let's see what it says. It's probably gonna be like, you should go on Reddit. Yeah, split wing with a spar through the body. Yes, because it's literally, no, not the cutout, no, because it literally digs through everything. How expensive is a 4 to 6 millimeter carbon rod? Let's go on Amazon. $4mm carbon rod. Oh, they're not even that expensive. $4mm by 200mm. It's like perfect, chat. There's only one. Oh, 5. Dang. I might think of getting a carbon rod. That's not really expensive. But you know, I'm saving up for other stuff. I don't got no money in for this. Got a sleeve hole, okay. In the fuselage, cut a matching tunnel. Make sure this tunnel is above or below your electronics blade, not through it. Side spar through fuselage. Ring under the sparling. Lock into place. Raise the wing. Lower the electronics. Wing settle only. This. Okay, I'm not gonna do the carbon rod just because I'm trying to keep it very minimalistic. I feel like that would be an expensive add-on for something. We're trying to just do a body swap, not an entire rework of everything. Well, that's basically what I'm doing, but I wonder if it's still going to be able to fit in this case. Probably not. Okay. Not a carbon rod though. can't do carbon. That's actually carrying load. Skinnier, not a skinny round rod. Okay, a box. 256 is the longest I can make it. Okay, so this box here, like the actual box of the entire thing. Oh, that's not really good. This wing cannot fit for nothing. That's why I'm gonna cut it and put the rod under the electronics. So, look, let's go back to paper here, and new page. So, let's do a side view. Here's the side view of the plane, okay? So, it has a box, and then a cylinder, and then a side box here, with the little bar that goes across, and it holds the electronics. It holds this long electronic thing in place, and then the battery down here. So what I can do is, for the back one, I can lift it up and put it through like that. I don't know if it needs two or just one. And then for this here, I can do 1, 2, but they'll have to be closer together. And it's gonna be really tight. Because this, and if it snaps, if that bar snaps, this entire project's over. Because it's going to be weighing like this with that little electronic bar above it, and if it snaps, it's just going to go straight into the motherboard right here and absolutely destroy it. So we need to make the wings as light as possible. Okay, let's just, yes, PLA and fill 40 to 60. Okay, that'll be actually a really heavy bar. 2 or just 1. Okay, 1 solid spar is enough. That's probably incorrect. I'm going to print it all, and it is going to just crumble. So, I don't know, I'm just gonna trust it. Even, I don't like AI. AI sucks. I've used it for questions before, and it was like, oh, your little battery monitor needs 6 gauge wire because it's going to be taking a full force of the battery. And I'm like, no, it's not. It reads the volts. Sir, it reads the volts. It doesn't take in the amps, too. Doesn't even take in the volts, it just reads them. That's like pressing the button of the flashlight. You're not staring into the flashlight. You're just pressing a button. Bruh. Okay, so let's cut the wing down the middle. So this is 45, meaning that the length of this, 320 minus 45. 320 minus 45, so 275 is the actual length, divided by 2. We'll do 37, or 37 is fine. No, let's lower it to 130. So copy paste, drag the secondary, 130, 130. There's one side. There's the other. Won't you take me to Funky Town? Won't you take me to Funky Town? Okay, and a good thing is because the motor has a little rotating piece, I can rotate the angle of this dial piece. So this is the dial piece that rotates the entire propeller. I can rotate this however I want, and as long as this axis stays the same, I can give it a little degree of an angle, which should be pretty helpful. So let's make sure this is lined up. There. That's perfectly lined up. Okay. 1, 2, 3, 4. 1, 2, 3, 4, 5. There. There's the layout of the first wing. So how long is the wingspan now? Is 305. And these motors have a wingspan of 350 stretched, which I don't like that. They shouldn't be stretched, because then that's how you tear something. It's like tearing your ACL while playing basketball. Okay, now let's do a 250 rod. 250. We'll lower this to 6 by 6. Okay, 250 might be a little long. 6 by 6. This is like a airsoft BB size. It's pretty small. How tall is this? Okay, I made the wing 130 by 40 by 10. So that is a chunky little wing. Like, bro. Yes, each wing half. 8 by 4. Let's do 10 by 5. I don't trust it very much. Eight 8.3 by 4.3. That's not a very good number. Well, these wings are supported, so it should be fine if I print them vertically. I don't know, let's just... Okay. I might have to scoot these wings back one more. I also need to add all the holes for all the electrical to travel through this. Here's the end of the motor. That's stretched and then resting. It's 45 on top. No, did I just... Oh, you gotta be kidding me. It's because these things are magnetic. They got that magnets in them. Please don't tell me I broke something. I mean, it all looks fine to me. Watch it never turn on ever again. Yeah, that looks fine to me. It keeps trying to fall off the table. So look, here's the little layout right now. So we have the back motors. These are going to be closer together, but they need to have a little travel room to go to the back. That's why I've been trying to get them closer to the back, so it's like a trapezoid. And then these farther ones out. So these ones are going to be how they are right now, where it's just flat pointing out. And then this little piece right here is basically going to sit at a little angle and a little body I build for it. And then it's going to take one of those bearings, so where it'll slide very smoothly. I think I might have lost one of the bearings. It's fine. Okay, let's get back to designing. But, so this electrical is kind of actually this entire project, and I don't want to drop it again or anything. So what I'm going to do is I'm going to put it inside this casing. Same with the battery. You know, it would have been really cool if this thing would have enough power to lift up this entire box. So the box itself was a drone. Okay, let's copy this rod. We have to move this back a little bit. Let's just delete that one for now. So how far front can we push this? That's as far as I feel comfortable pushing it forward. Okay, let's regroup all this. So the center of gravity is going to be like about here in the middle. Right about there. So let's grab this bar here. So it's 10, so let's do 10.5. So it has a little wiggle room, and then heighten it from 5 to 5.5. Now I have to perfectly center this too. Okay, so this is 305. 305 minus 250. So we have 55 divided by 2. Well, 55 half intervals. Not a lot of room. Okay. Halves. Oh. Oh. Oh my god. I grab that one. 55. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50. Okay, does that look center? That looks center. Now we're gonna hold it. Do we have to slide it down? Just a little bit. Just a tad. It's perfect. Okay, now shift, Control C, movie. Move it over here. I'm gonna group that and then delete the 2 wings. Body, group it. So now there's a hole running through it. That's gonna have a tight fit. That is perfectly lined up. Cool. Now we have the back side of the plane. Let's just hold and hold. Screenshot. Let's see what it says. My file didn't come through. You gotta be kidding me, man. I'm just gonna jump you, bro. I'm so good at spelling. Trust me. That's because electrical spelled Electrical. I'm just gonna super glue it. These wings are never leaving. You want it to be removable but not sloppy? Screw that. Not later. No. I am going to screw that. Like. No. I'm just gonna super glue it. I'm just gonna super glue it. I'm so good at this that I'm just gonna super glue it. Okay, so we have the front wings with nothing attached to them. Okay. Now let's the really, really hard part now. So the motor, the little motors. Let's measure them. So we're gonna measure the motors. These little gear shaft things. We're also gonna measure the length of them. We're gonna measure the little bearings. I think the bearings just slide on top. I'm gonna grab that. Okay, that's really good. The bearings stop it from sliding anymore, like that. And then little wing goes on top. Like that. So basically what I gotta do is I gotta make a little shaft to just hold this in, and then yeah, I'm on my own. So how long is this? I might have to redo the wings. Okay, this is 15 tall. I might actually have to redo this. Oh wait, no, because I'm making a custom housing. I'm making a custom housing. Let's go! Okay, so basically, let's just zoom out. So here's the, this is very rough. I don't know, let's just do it on paper. So, you can't see that. So here's the little motor. This is the little motor, okay? Little motor has the little sprocket on it. Now that sprocket fits into the larger wheel sprocket that has an indent, skinnier indent with a bearing on it, and then the D on top of it, the double D for the propeller, so it actually grips onto it. And then it has a little indent and a peg for it to easily slide. So I'm thinking that I just put the motor in. Well, of course I'm going to put the motor in, but I'm going to have the motor and then build a little thing around the housing. like that, like a little shaft, a cylinder, so where it looks like a rocket, like that. Oh, looks like a rocket like that. There's a little shaft, so where the motor is going to be on the side. So where the motor is going to be on the side, and then the actual shaft, like this, is going to be up here. I think that's what I'm going to go for. But the thing is how precise this is going to be, so I'm thinking of making it a screw-on, so where I can print that part, put it together, and then add it onto the wings. Okay, let's see. Let's go back to this. This looks like it just cuts off to it, so it has to be. So here's our cylinder. How much? Should we give it like a 8-degree rotation? 10-degree rotation. That is just so little, you can barely notice it. And then let's hollow it out, but let's measure this first. I have one right here. So we also need to make it removable, so where I can just slide every individual piece in. So what I mean by that is here's the 3 pieces, and then the motor's in here. So what it's going to be is like a little housing that I plop this into. I plop this rotator into the housing. Oh, let's just use this for now. So here's a little rotator. I would plop it into the housing, slide the housing under maybe, so where it goes onto the motor, put the bearing, and then put the propeller on to tighten it, and then maybe some screws to hold it together. Because the original plane, drone thing, had 3 screws holding the shafts together. So I think I might do screws, or I might just do super glue. I have lubricant to make sure all these parts slide smoothly though. And then I also got to tighten down the motor somehow, so where it doesn't slide around or whatever. So it's basically gonna look like a canister. Like that, basically. So that allows for the motor to go in, the propeller to be held up to, this rotating piece to be held up, and then the bearing to go up to a longer shaft, having it all complete. Dang, it's been an hour and a half. Dang. Okay, well, I kinda gotta grab one of the old pieces for like design. I don't know. I hope after I do all this that it is repeatable. Yeah, so it just needs a little hole on the bottom. So let's do a bare bones. Delete that. So we have our bottom cylinder. How large is this gonna be? I think we should do it just a little bigger because 3D printed. Like 25 is too big. 25 is a little too big. No, 25 is fine. So 25 by 25. And then for detail, we can also extend it, make it a little longer, or make it like a cone shaped, like a cut-off cone, so it looks like a rocket. And then, so we have, there's our base. How long does this shaft stick out? And this shaft sticks out 4 millimeters. So it sticks out 4 millimeters. The shaft itself is 12 millimeters, so it should be 8 millimeters after I drop it into here. Theoretically. Let's just set it to 8. Set 8. That is at 8, so it has to be pretty exact then. So 4. Where's our rotator? Here. 8. So 4 is how tall the shaft is. We want it to have a 2 bottom, so 6. And then get another hole. This. Get a 4, 4. No, not 4, 4. No, we need diameter. Diameter. 3. 3 will give it just enough looseness. And then move it up 2. Center it. 25 to 3. 25 to 3 is 22, so 11 on each side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, 11 falls. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, Boom. Group. Okay, there's our little base shaft of this. Now we need the entire casing. You know you love. There's no right to wrong, just wanna make it so okay, it is 20. That is 20 in diameter, so 22 giving 1 on each side, right? Or 23. No, 23 is fine. And then 23. 22. 23. How tall is this though? Up to the bearing. Up to the bearing. Looks like that bearing is up to the indent. The second or first one? Okay, I'm gonna grab second bearing. Second indent. You know your life. That is 8. 8 tall. Oh. Bro. Where's that? I gotta lock it. Okay, there's a little. There. I can move this up or boom. Start back to 1. Group that. Okay, then now that's a little indent for this up to the bearing, so it still needs the top section. I also have to repeat this 4 times, but that doesn't matter right now. I gotta do the motor mount. You know you love it. Let's just say 9. How tall does this sit? Or do you think I should just make it adjustable? I actually gotta make a motor hold. And I think that, let me move it down so you can see kind of both. So this little rotating piece, I think that it'll stay in if I put this on. And then I can screw it down, meaning that I have that little room to put the cover. So I could just make a little cover for the bearing to sit in. You see? So the actual propeller itself will hold in the cover, meaning that as soon as you unscrew the propeller or screw it in, it'll tighten and loosen the little rotator. That's pretty good. So let's actually measure that. I can just do that right now. The motor is going to be a while. Three millimeters. I can do 3mm 25 with the little indent of the bearing. So I could do 5 because I'm guessing that's 2. And then, so I just gotta measure the bearing now. Bearing itself. I keep referring to this as a bearing. It's clearly not. Seven. So flatten this down to 5. 25. 25. That. Now I'll get a little hole like this to go 7 by 7. Next. Then 25 minus 7. Yeah. 25 minus 7 is 18, so 9. And lift it up. 1, no. So there's a little more space for the bearing. Oh, it has that for the shaft anyway. I'll just continue it all the way down. There. So that'll hold the bearing, that'll hold everything. But that little bearing will have room to move up and down. Oh, wait, I can't do that. Okay, what I'm gonna do is I'm gonna undo that. I can't do this. Not really. Although that bearing is thicker than that bar. But by how much? Let's just bump it up to 5. So bearing. Now it won't get past the bearing. Now I could, if I wanted to, I'll just do a 1 millimeter hole to hold the bearing. So 7 by 7, and then lift it up until it just sits 3.5. Perfect. Okay, so now all I need, because that goes on top, and the propeller would lock it in place. Now all I need is the motor, and then to set the wires and finish the back wing, and then do a front flap. Dang, is it hour and 40 minutes? It's been like 5 hours since I started this project. 4 or 5 hours. This is gonna be like one of the longest YouTube videos I post. And I've been talking through it all. Like, so no matter where you click, you have entertaining stuff like this. Here, how about I do this? If you comment the Statue of Liberty in white, I will personally shout you out, and like I will do something. I don't know, if you say the Statue of Liberty in white, I will do basically whatever you say, because that means you are actually sitting here and watching the video. Like, I mean, if you say, go to Walmart and scream at the top of your lungs, I am doing that because you actually sat there and watched through the entire video. Unless you miraculously clicked on it. I clicked on this exact like 1 minute period. Okay, well, let's just continue. So, now we need the motor mount. So, we can make it a little wide than tall on the holes, and then have it be a screw down. I'm gonna go grab some more of those longer screws, because I'm gonna need a bunch of those. Oh, I didn't pause it. Okay, well, I'm back. And I brought 8 more of these screws. So these are just screws I stripped from a Nerf gun. I could like leave a description of what they actually are. They're just longer ones. I'm gonna use. Oh, do I have more? I'm gonna see if I have enough to use 2 for each. Well, 4 for each motor. I'll be right back. Okay, I just barely have enough. So, if you're like watching this video to follow through with this, which is a very bad idea, I don't think you should ever duplicate this, but you can just find like, I think it's like any drone, really. Any like Walmart drone or like Amazon drone. Not super expensive drones or whatever. Just like a small drone. You can just follow this. If it's the same style, maybe you could even use the files or just edit them a little bit. Because if you do edit the files a little bit, then
you could, because I don't even know what the actual name of this drum is. Like, generic? Like, there isn't like a set name to the drone. So, I mean, I'll release the files on probably Maker World, Bamboo Studio, or whatever. That's where I'm probably gonna release the files and then this video. So if you want to duplicate it, which I don't recommend, you can. You can like edit all the stuff to your own settings or whatever, your own printer. Because this is kind of a little bit of a big one, because the longest piece in this print is 250 millimeters in length, and most printers don't even have that amount. So let's just get into making sure this motor will fit. So right now, this part right here, this part, like this upper one with the smaller hole, that is the piece that holds in most of the shaft. So it'll sit in that like there, meaning that it'll just have a little bit of space above it. Let's grab this again. Okay. That sits flush. That sits parallel. That is really good knowledge. That just made everything 10 times easier. Okay. So what I can do is I can copy paste this, move it over a little bit. Degroup it, and then delete this upper part. And then this is like our little base. So then all we need to do is, how tall is this? 6 millimeters. Sorry about that. That only took like a little bit, but so now we know that this is, does that say 6? Yeah, 6 millimeters, right? Okay, yeah. It looks like an 8. Okay. So now we know that that's 6 millimeters in height, meaning that I can I can just heighten this, put this 9, so that's 9. How the top of the screw is, 4, 9 plus 4 is 13, 14, 15, 16. I'm gonna make this 16, throw it in so it's completely inside. Center it. There. Hold that. Group that together. Boom. Now we have our little base. Fits right on the edge. Boom, now we can lower this down to 6 millimeters. Boom, I did not center that. Whoa, whoa, chill. Degroup it. I got it though. Whoa, whoa, chill. Is that all that took? Or what is a man? What has he got?
If not himself, then he has not to say the things he truly feels, and not the word of one who kneels. The record shows I took the blow and did it my way. Okay, so I'm not planning on doing any rest of any sort, but what I'm going to do is a overhead bracket. So like, boy, shoot, boy. Group 950. Wow. Undo. So close. You know, always check your measurements and stuff. Whenever you're doing any project, always thoroughly check your measurements. You can be off by 0.25 and it'll screw everything up. Check your measurements. I am telling you from experience, you do not want 20 by 10, so if that's 9, if that's 16, I want this to be 14, and then this to be 7. And then cut out a oblong hole. So if that's 9, 8. By 10. Let's until it's off. One, two, three, four, five, six, seven, 8. Wait, hold up. There's no bottom cavity. Like there's no indent on the bottom. So this is the entire support, basically. So let's just do 16 by 8. We're gonna put that there. I keep trying to swipe down. There are no items, just in one okay. Boom. 9.5. How tall? I want it to be tight, but I also don't want to crush the motor. I can just do that by tightening it differently. That's a little weird, that's fine. So basically, how am I going to do this? Better do it on paper than just because it's easier to write on paper. So here's the motor. Here's the bottom plate. I want it to be tightened down. So on bars, a bar like this. And this screws. So basically we have to build a little off that. This is actually taking a really long time because it's super difficult. So 13 of these. And this is, the smaller one is 9.5. Yes, correct. Whole group. So like this, but okay, wait, I'm gonna copy it. I'll decroup it. How tall is this interval? 10. 10, so we want it to be 7 because we're long enough. So if I cut out 3, leaving 4, that's good. Cut off 3, leave 4. 1, 2, 3. There. Now all we need to do is make the holes. But let's first undo. Control C, Control V. Control C, Control V. So this one needs to continue up. This one to continue down. Group. Move. I just need it long enough to hold the motor. We're making really good progress. That is 22, so 20. Oh, dang, it's already 20. That means we gotta extend this a little bit now. Tall. So at its tightest, it's 7. So it leaves about a room of tightening. So I think I should just center a hole the size of that. So I can plop it in, slide that in, and then tighten it on. This is actually going through a lot better. Right, okay, a hole 5. Let's just say 5. The entire thing's 9 and 5, 4, 2. Bring it up to off this plate. Seems about right. I might have to do a cut this one too. Rotate that into place. And more. No, it's just really high off the ground. Just keep the thing. Roof. Okay, there. That's what we have so far for the motor mount. That's actually looking really good. That can't be in. Wait, hold on. I forgot that this thing can't be in at all because it has the raised piece. It has the piece above it. Boom. Now I'm gonna take this, rotate it 90. that's how the motor is going to be looking, and then the propeller is going to go on top of it. Like that. And then I want to make it look like a cannon, like a rocket on the bottom. You know what I'm talking about? Like a little cone, the little indent. And then after that, after I put the screw holes, I can copy it to all 4 wings, but I also gotta do the back wing. And then what's that thing called? Tail fin or whatever. And then this is the designing part should be done. But you know, this is never gonna go like this. Probably gonna be 3 hours into this video by the time, but half my phone's battery in 2 hours. So I have another 2 hours before my phone dies. And okay, the first thing we should do is just get straight into the holes of this. So it needs this, because this isn't a flat shape, it needs the starting holes and then the drill holes. Meaning holes that the caps rest in, so it's not at an angle, and then the holes that the actual screw part of it drills into. Basically what we're going to do is we're going to design up a screw. Okay. There's 3. So we'll do 2. Yeah, let's just do 2. So 2 by 2. And then the height of it is 10 in length, but I think we should do 12 just to be sure. And then the thicker one for the top. Not that thick. An 8 or I don't even know her. 4. So we'll do 4.5. And then 4.5. One, two, three, 4, 5, 6, 7, 8, 9. Okay, there. Okay, so we have our screw, so that this is what we're gonna template and just put into the little thing that we have right behind it, the red. So let's first put it back into 1mm, because it's just easier. basically what we've done this time is that we've halfway through the wings. Oh, we also got to do the wire. We also got to do the wire ports. This is a solid piece, right? Yeah. Control-C, Control-V. C, Control-V. Okay, there's the screw holes, like the areas of where they would go. Now, let's take this Control-C, Control-V, and move it out of the way. And then Control-C, can copy all of this. Control-C, V, and move out of the way this way. Now we can delete the middle one. Group that. Group that. There. There. That is the motor hub assembly finished. Let's spice up the bottom. So this is a cone, right? Oh wait, hold up. It's been a really long time sitting this here. It took me 15 minutes just to do that one piece thing. Okay, well now I can move all these screws. So that has 2 screws for the mount. So no. So all these bigger screws. I'm gonna try to pick up just those. There. I think that everybody should get just like a strong magnet just to hold all the screws, so where you don't have the chance of losing one. They're all stuck together. And like I can like throw this and it won't lose any of the screws. I just think that that's a really good thing in a workshop when working with small things like RCs. Okay. Well, now that we have our assembly, now we have to put it on the actual plane. I'm gonna clean up my area a little bit. C, Control V. Put it down a little bit. That looks good. Move it more forward. Where it's out of that dead zone. I shouldn't be seeing any. I should only be seeing red through those. No, see that? I should only be seeing red through those holes. See how deep it is. It's still connected really well. There's a solid piece there. Boom. I don't think it looks good like that. I might be able to. I can just make the holes up here. I think that would just be the easiest way. I'm fine with that. Well, that's close wires. can rotate it. Oh wait, yes I can, because then I can angle it. Because it's a mirrored part. Yeah. Rotate it 20. Boom. As soon as it's flush. Is this one the same? Yes, as soon as it's flush, right? Correct. Boom. We did it. Now we just need the back ones. Back fin. Back fin. Plane. Back fin for the plane. Okay. So it's a little slight, like a weird oblong trapezoid. So we can get a triangle. That's a little more smooth and that's a little more steep. No, not 45. That's the original long length. When it's skinny. 10. Oh, it has to be a lot taller. Yeah, I don't got a lot of time, so this is I'm not really sure how to really design one of these. I just gotta finish designing this back. This is probably the last thing I'm gonna do today. I think I might just not have one. Or I could just do a little one. 45 minus 21 is 24. Yeah, 24. 12. It's edged out. 1, 2, 3, 4, 5, 6, 7. It just looks stupid. Okay, let's copy the wings. Control V. So if I would just put them like this, it wouldn't look good. That's why I'm gonna make them smaller. So D group again. No. 1, 2. These are separate pieces now, yeah. Then what span should be the wingspan for the back wing? Longer than that because it's a 45, so it's 305 total. 70%. $305. $305 for the body. For the front. Main wingspan is 305, yes. $190, okay. Minus the 45 millimeters part of the body divided by 2 because they are separate. Okay, body 2, yes, 130, 60, 130, 156, 82, 80 to 90 per side, okay. Let's see, 80. That's fair, yes. 80. Um, 250 divided by 305 is 80%. So total 80 times 2 is 160. No, 80, 160, 40, 45 is 200. 200 minus 80% of 200, so 200 times 0.8, 160. Let's recalculate the gap. 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, that's flush, okay. And then 160 to 205, right? 160 to 205. 205 minus 160. That's 45, yeah. That's not how much I need to move it over. Okay, 45. Let's just move it over 45. 22 and a half is 45. If I move it back far enough, I don't think it'll be touching the battery.
Yes, Daddy. Okay, sorry for that mishap. It's been like 15, 20 minutes.
Man, my computer's about to die. Okay. Where were we? Oh, we were creating our own drafter. So, here's the little problem that I have right now. So, this is the battery right here. So if I do put a long bar here, the battery is not going to be removable. Oh, wait. It doesn't have to be removable unless it blows up. Then I can just redo the entire thing. It's as long as the battery can slide out, it's fine. Because look, this battery here, as long as the battery can slide back all the way so where I can access the little charging port, it'll be fine, and I can pivot it. So I slide it out and then lift up the front and pull it out. Yeah, that'll be fine. Yes. So far. What was that? Yeah, there's enough meat. 3 to 4, yes. The cover for the top gives only clearance, because you see there's like no clearance back there, and I can't shorten it because the battery doesn't fit. Tight squeeze. Yes. Okay. No, it's as low as it. No, it's the cover for the entire thing. Okay. I don't know, it just wants to fight with me. Okay. How to model the tail. The vertical one, the one that sits like that. Mm-hmm. Yeah, vertical fin. 50 to 70. Okay, let's go back to this one. This has like a dual drop down. Let's see, what are the dimensions for this? This one's also higher. It's just hitting the edge of the angle.
She does know that it's 12 degrees outside because I let her in right before I let her out. So she does know. Did you see how many they bought?
Okay, Control C, Control V. Now we line it up. Rotate it all the way around. Rotate it a little bit.
So how much does cable cost? I know. No, I'm just saying, how much does cable cost? Because I'm trying to think of the last thing you bought. It was like $70, $200 a month.
added the back side. Just need vertical fin. You help make one that isn't just a block, but fits this style. Okay, so basically what I have so far is pretty good. Okay. So basically make it like a clip, like a anyway, hold up. Let's see how long this is. I don't know what room I have. I have 16. That's not. This is actually a really fun project. I recommend if you want to do something like this, this is a good starting position. I 15, think would look good. $30. Yeah.
Sorry about that. We're running back into
The design. So it looks mid. Oh, we gotta center it. So this is 15. This 15 to 45. Is 30 or 15? Oh, let me. Away. 3, 4, 5, 6, 7, 8, 9, 10. Oh. Screenshot. Looks a little weird for some reason, chat. Keep the trailing edge vertical or slightly swept to fast.
I know, but that's what I'm saying. That's why I'm like, oh, Texas. I mean, you go straight across and it's going. But I mean, I don't want to die either. You know, what if we went to Yellowstone? We've been talking about that. Oh, who's Yelloway? Probably just kind of fell off a little bit. Although you actually get your locust. I'm already going to get the soda, but anything else before I leave here because I don't want to go back and forth. I'm not. And after the game starts, nobody can walk into the gym. So you're making it fuzzy. Where's the soda? On the floor where it normally is. What? On the floor where it normally is. Oh, I thought you already had a soda. Go get a soda. I just said grab the soda, so I got that milk. The one he already had. You said grab the soda, meaning the one that I already opened. And so I was like, where's the soda? Mom was like, on the floor where it normally is. That's not, go grab a soda, not. Oh, you drink all of it? Yeah, I told you there's none in it. Oh. Oh, okay, so see. I thought she got that register soda. Okay, so mom was the one that did that.
bro, what do you mean my computer died? Right, cut edges out of the sides. It's much better now. Okay. I already did that. Now I just have to connect the wings. Okay, what I'm gonna do right now is I'm gonna move my phone, my computer, to the charger. I'll be moving it right now. Okay, so we got a new area, but okay, so we got a tail. So let's connect the tail, the body, group, and then we can delete the battery. I'll make this as 160, 250, so 249. I'm gonna make that one a little shorter. Then 160, do 19, and then I'm gonna take these 4 parts, move them out, rotate them. That is the template piece. We have this, which there's 4 of. Then there's this, which there's also 4 of. Man, there's a lot of work gone into this. Okay, now we have to cut the holes out of these, group these. No, not yet. Degroup. C, Control V. Places. C, Control V. Right over a little bit. Then I can delete that one. Delete that one. Group. No, no. Group. solid. So now I'm gonna group these three. And group these three so it shouldn't, yeah. Okay. Now we can move this back. C, Control V. Degroup. And delete that and move. Okay, boom. So now the wings are all placed. My shoulders. So now what I gotta do is I'm just gonna cut out small indents on each side for the wires to go into. They don't need to be super big. I'll be right back and measure them. No, I forgot to resume it. I just went, okay. Basically what I did is I measured it and then I cut out these grooves. So where the wires will go, and then this panel over here would go across the top, holding in the wires, and then holding in everything. And that panel, I'm just probably gonna tape it in. Same with the wires that go across the wings. I'm just gonna get a little electrical tape. That should be everything for the designing process. So let's group all of it into a few sections and slice it up. So first thing we're gonna do Bana. 1, 2, 3, 4. It's 4 and it's 12. Okay. What is this? This is 249 by 134. I can group that. I'm not gonna group these. Boom. So lemon shapes, group them together. Export as an STL. Preparing for export. Okay, taking forever. No, I'm not gonna delete that. I'm just gonna save it over here. Done. Oh my god, bro. Done. I just already know.
And I'm like,
I
what?
already.
And then it goes like this, and she's like, no, it's here. Yeah.
Why am I floating? Why? What? 9. 9. I feel I gotta redo that. Let's just throw this one in there with them. Small parts. Quadcopter. No. What is it? Ouchie. Oh, what is happening upstairs? Okay, bro, what is happening upstairs? This thing's taking forever to export. Remember, my target was under 140. This is probably going to be a bit more than 140. I'm probably thinking it's going to be around 200. What is the weight I'm going to do to hit the total? Is 140 grams with 60 grams of required components. The electrical and the
It's pretty good, you know. So, do you want me to do that bit with that thing?
Hey, at least it was just for them and not the eggs and everything and stuff. Yeah,
comfortably. dang guli 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 wata ding dang gu ding dang gu ding dang guli 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 wata ding dang gu ding dang gu ding dang guli guli wata ding dang gu ding dang guli guli wata ding dang gu Group them. Let's go. Export to STL. Okay. Nope. Change it to wings. Export to STL. Let's restart. Okay. I found it 29%. Are we serious or not? Okay, well, just gotta wait for this to finish, and then we can pull it to the slicer.
Okay, looks like it just went and finished.
So, let's go bring it all over to the slicer. File, import, wings, main body, small parts. No. Add 3 plates. So drag 1. Dang. Arrange. Slice. $173? Okay, this is 79. How much of supports? 14 of supports. This is already the lowest I can do it. So I'm gonna print those up. It might be a little bit until they're done. It says 6 hours right now, but it could take longer. So that's the end of this video for now. But
Okay, so it's gonna be a while for me, but you guys is probably just gonna like cut to the next section. So let's end it here. So I was putting this together and I realized I wasn't recording. So I'm just a little bit ahead. I have some of the parts here. Hold up, let me erase this. It's super short. But so far all we have some of the parts. I don't know if you can hear in the background, but more of the parts are on their way. But we kind of have a few problems. So first of all, it is way too forward. I mean, it's a tester after all, but you can kind of see that's gonna have no room whatsoever. So we have the 1, 2, and it's super tight on these also. So what I'm doing right now is I'm screwing the board in. Also, I misaligned the holes, so it's only supported by one side now. Come on. I don't know that. So the holes are misaligned. It looks like there's enough clearance for the beam to slide through. The front beam. Yeah. There's enough clearance for both of the beams to slide through, which is pretty good. It's good to know. But this is a really good benchmark for, like, to know where we are. So now we know that we have to redesign. Push it on. Oh, does it not fit? Okay, I made it a little too short too, so I gotta lower this or raise it. Let me see if we can get the battery in. Take the beam out. Oh. I think we might have won. Oh. Sorry, man. Okay. I'm gonna lower it and raise it. Ooh-wee, okay, that's a little high up. I got this little foam pad thing. Boom. Is that lifted up high enough? Let's look at the original housing. I'm gonna go. So this is the original housing. So the battery would slide into here. that's like where the battery is, and then the battery would slide in like this. That's not gonna work. It would slide in like this. That's still, there's still a bunch of clearance there. I don't know why this one's not fitting. I'm going to, where's my screwdriver? Here. Switch the bits. Where did the other bit go? This is a really good benchmark though. So now we know that we need to move the entire thing back. And we can move it back a decent amount. Let's see, let's just put a bar through the back. Alright, we got a bar through the back. Take that out for now. Yeah, and we can just move it all the way back and then pull it up. So we can move it back a decent amount. Dang, this is really hard to unscrew. I wonder if I just measured it wrong, or it actually cannot fit. Nope, that's enough room. Okay. Yep, that's enough room. Now if I plop it down. Dang. Those are stripped. Boom. It's good to know that it's on. Okay, and then let's put together the propeller assemblies. What's happening upstairs? Okay, I kind of lost one of the bearings on accident. So one of them's just gonna have to go without a bearing. See, just assemblies. I believe it's just one of these screws. Boom. I'm actually going to loosen it a little more, just so it turns more smoothly. And then when the wings finish, we should be able to just slide this in, slide the motor in, and then tighten it. They're just coming together really well. Okay, so I got to find that bearing, because I don't know if you see that, but it just slides all the way down to the bottom. This entire thing is screwed if I don't find that bearing. I'm getting lubricant all over my fingers. These gears. I'm just gonna grab one of those small screws. Plop the screw in. Tighten it with the screwdriver. That's 2, 3, and then I'm just gonna try my best to find that bearing, or I'm gonna have to like find one online. Or I'm gonna have to do something. It literally won't work out. I'm gonna see if I might be able to print one. If I don't find it. But there's a lot of things I gotta redo of this body. The major things is the top actually fitting. With the three wings. No, I need to find the bearing for the fourth one. And then it's coming together though. So now it's just the waiting game. Well, I'm gonna look for that bearing, but now it's just the waiting game from when the wings finish. Once the wings finish, I should be able to put it. Well, I gotta redesign this, but I'm gonna look for that bearing. It'll be a little bit. Okay, chat. So let's get our little weigher over here. Let's see our so far weight is probably going to be a really disappointing number. So it's still not done. I got to extend the wires, and it's probably going to max out. Yeah. So what we're going to have to do is we're going to have to counteract it. That's pretty heavy. Throw those on there. -90. Okay. If this maxes out, I'm gonna absolutely throw it. Ooh, okay. It's 130 grams without the wings, without the propellers. We're kinda cooked. We are kind of cooked. I gotta find that bearing though.
That bearing is the key to life.
So I'm gonna look for that bearing. It'll cut to I found it, or it'll cut to I'm designing it. Ooh, I found it. Let's go. Okay. Let's put that assembly together. Let's just slap that there. Okay, we have bearing. We have bearing. We will not be safe. We will never be safe. Let's go. It fits like a glove. This is what sleep deprivation does to somebody. Oop. That's on. Loosen it a little bit. A little more. Perfect. Okay. We have our our four propeller setups. We have our 4 propeller setups. We have somewhat of a body. And then we put this away. So we've actually, I'm so surprised that we've actually made this much progress. So looks like the last things we have is the actual wings. I'm gonna clean up my space a little bit. So we have the wings, propellers, wings, propellers. We have to redo not the entire body per se. We have these topical parts. These parts hold in the motors, very small motors. Okay, so this is the old LED lights. This is the old LED lights. There's 2 wires on them. I don't know if that'll be enough. If not, I have more wires. Let me go get those. Okay, so we have our little box of spare wires. We have thick, we have small, we have long, we have short. This red wire, like maroon, like the darker red, looks like it'll be really good. Try to get that out without cutting myself because copper is very sharp for some reason. Okay, this looks like just a bunch of pieces. So we need 2 each. So 1, 2, 1, 2. There. Just throw the rest back in there. Where is it now? Throw it under here. Okay. Now we got our wires. This is more than enough wire for it to expand fully. I do believe the electrical tape will be more than enough to hold it. We're gonna have to redo this top though. It doesn't sit all the way down. It's pushing on something. Weird lighting up here right now. Let's take this out. I don't have wire strippers that fine. I'm gonna go. Sad. Let's just grab one of these pieces. See if I can strip it with. I don't know, I've worked on electrical before, but not with this small amount of gauge. I've learned to slowly cut around and then pull. I don't know if that's supposed to happen, so it should be fine. It's a small enough gauge anyway. That doesn't look like copper though. I will be right back and I'll ask somebody with more knowledge than me to see if this is fine. Okay, so I learned that the inside of those rods are aluminum and that it's just not as good as a conductor, so we're not going to be using any of these. We gotta go back to the wire box. Look for some copper ones. I mean, I do have a bunch of 6 gauge. Might be a little bit big. Just a little bit. Oops, got it. This is a little thicker. Okay, this will work. That should be enough for all of them, I believe, if that's really thick. Other than this clear one that looks like the smallest one I have. This clear one might actually work really well. What is that? What is that? Yo. An aux port? So like here's this dual, like, clear, so we can see the copper through it. It's like really weird. But it has like this weird like aux port. I wonder what happens if you plug that into your computer. It just blows up. Like, what is this for? Well, we're gonna use it anyway, so. This is a little too thick. So we just need just enough to get it going. So right now all I'm doing is just unknotting it. It's a little knotted. Straighten it out. Cut off whatever this is. See, I don't even know what that was. Okay, there's like crystals all over it. Bro, what is all over this? Are we? So I don't know. I'm just gonna cut that off. Okay. Can you see that? No. I'm gonna try to very carefully snip this. I'm also gonna fix my battery monitor because something is seriously wrong with it. That thing was clearly dead and it was reading. it was reading like 3 bars down, like 2 bars down. Even though it was like completely dead. There was no life in that thing, and yet it was still reading a bunch of life in it. Okay, so we probably need... There, first one done. Well, not really. Still gotta clip that. And then... let's make them the same length. Again with all that weird stuff all over it. Start from the other edge. Nope, it's still here too. I don't know what it is. I'm just gonna cut it off and get rid of it. I don't wanna be breathing stuff in. I don't even know what it is. If you don't know what it is, you probably shouldn't be breathing it in. If you know what it is, and it's probably bad for you, you should not be breathing in it. Just trying to strip it. It's wanting to leave, but it's not. Oh. Gotta straighten it out. God, that splits. I just need to split this one. There. Dual split. No. Red or black, guys. I'm gonna see how long is left on those wings. Dang, still an hour and a half before those wings are done. I'm still gonna fly it today. Who's gonna stop me? I'll take the tape off this one while I'm working on it. Okay, this is gonna be really hard. I clipped it. Holy, that is small. That is really small. One of them. That's an aluminum, bro.
Great, I guess. Okay.
Get some electrical tape ready. So, I hope you guys know I have absolutely no clue what I'm doing. Like, I genuinely have no thought process. I know cut, connect. Okay, there's one. Mommy Jimmy rigging this, yo. This is about to be the most dangerous, like, drone plane thing ever, bro. It's about to be more dangerous than the 40-kilo metal Beyblade. Literally just blows things up. It takes chunks out of concrete. Like, okay, got the first part done. Outfit, right? So basically what I'm doing is I'm folding it over on itself, so it has a little area for the actual motor wires to go, and then I'm gonna tape it around. I have to do this again. Put it more in view. So I just gotta strip this one. Get this one already. Hyper razor, things just See, that wasn't so hard. That wasn't supposed to cut. Boom. Got that boom, 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 boom. Okay, this is black. That is white. We may have to do this again. Okay, done. When I turn this on, it's either gonna explode, or it's gonna melt, or it's gonna work. It's one of the first two options, I bet. Ooh. 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 Do do do. Ooh. Okay, I did something wrong. did something really wrong. Okay, it's not blowing up or melting or working.
Yeah, but he's okay. I probably got a couple of screws from my head loose, but no words of what's going on. I'm not gonna say that. But it's cool to talk green. I'm not gonna say that.
Still recording. Oopsie. I forgot to pause it. Okay. Well, I'm having a problem right now. So, the problem I have is I think I might have swapped them, but this motor isn't turning on. I think if I pull it real hard, it'll swap. No, it'll like come off. So I'm just gonna. Well, those are set like that. So let's just open this one up.
Holy shaja. That has like melted plastic on it. No, melted like tape on it. Do you think it like heated up a little bit? Okay. Eeny, meeny, miny, mo. I'm the safest person with electrical. Oh, speaking of electrical, safety and electrical, don't do this with the battery still plugged in. Yeah. I gotta go really quick. Mr. Beast, they're done. Looks like they came out really nice. Oop, almost just threw those on the ground. One. I still gotta finish wiring that, but that's not a job for right now. Looks like it maximized by utilizing the same support. So because the parts are really weak, I'm gonna very carefully cut it out. Well, that came out real nice. Yeah, I don't know why people use all the supports for PLA or whatever, or like supports for PETG. I just think it's a waste. All the stuff that I print comes out perfectly fine. Any of the cleanup is very minor. No Diddy. It should fit the motor perfectly. Correct. That looks really big. That's because it is really big. I'm gonna have to redo the wings. It's really tall. So doesn't fit, but we can get a rough see on how it. So this is a very good start to just preview it, see how it's gonna look. Yeah, those came out really big. You can just you can clearly see that's way too big. Looks like it would hold the motor though.
the longer wings. So like this, long shaft goes in. Well, I do know one thing though. Monday through Sunday. These problems, they come and go. Monday through, Sunday through Monday, no. Saturday through Sunday, Monday through Sunday, yo. I'm crying. It would have worked out pretty good. It's a good rough estimate. This should not connect. Correct. That's gonna take a while to set. This is a really good benchmark. So now we know a few things. First is that I suck at designing. All the measurements are wrong. That's not the point though. I think this is a very good start. I'm just gonna start. This is very structurally incorrect. I think I would have better luck with electrical tape. This isn't going really well. It's a start. That's all I'm gonna say. This is start. No further comment. Bro, are we serious? Mr. Krabs. Straight ball in chat. Hamster. Yeah, I'm gonna have 10 times better luck with electrical tape. I'm just taping it in place. So whatever this is. Still wants to escape. You'll never be sad.
What happened to let me know when you're done, dude?
I did.
When?
I literally went over there and said I just finished. Yeah? What do you mean? What do you mean? Okay. First one in place. Let's just turn it on. Where did I put the controller? Yeah. I think I might have broke the controller when I dropped it. I think I'm professionally cooked. Oh, it is not looking good in there. Oh. So cool. I don't think this is fixable, check it. Chats. Shakalicious. No. Just the board's so fragile. I think this entire project is over. I don't think there's a way I can fix this. I'm gonna go grab my computer and ask. So many problems. First, design the top cover too small. It won't fit on top. Where's her too short? And then extensions. The shaft. Structurally. Please help. Okay. This is probably going to be the end of this video for today. I'm going to work on it to try to see if I can fix anything. But that's going to be it for today. Goodbye.